Hello, everyone, and welcome back to day 3 of the Dynamic Spectrum Alliance Global Summit. We're in the home stretch here, and to kick the day off, I'd just like to acknowledge on behalf of the Dynamic Spectrum Alliance the sponsors who have made this event possible. They include the Access Partnership, Amazon, Aruba Networks, Cubic, Facebook, Federated Wireless, Google, the Internet Society, Loon, Microsoft, and Policy Impact Partners. Next slide. So we have an exciting lineup of topics and speakers today. We'll hear keynote talks from both FCC and Ofcom, and that will be followed by a session on sharing spectrum while protecting incumbents through multi-stakeholder collaboration. So we'll hear some live experiences from regions as diverse as the US and Mozambique and Peru. The next session after that is the from Microsoft on corporate social responsibility. As most of you know, I think Microsoft has been a tireless champion of dynamic spectrum and has also played a key role in supporting the development of networks. So we'll hear about that. And then the last panel session of the day is looking ahead to WRC 23, and that obviously has huge implications for things like 6 gigahertz and beyond. And that will bring us to the end of the day, but there are also pre-recorded sessions, which I highly encourage you to take a look at. One is on TV white spaces, opportunities and challenges to scaling. So looking at existing efforts on TV white spaces and what is holding them back and what are the opportunities for doing more. And in particular, I'd like to recommend the session on alternative communication models for connecting communities. I think that there's often a focus on a purely commercial approach to developing access, and what's explored in this session are other approaches: cooperatives, community networks, municipal networks, and so on. So with that, just a reminder of how this particular interface all works. If you look at your interface, you'll see the stage button that will take you to the live talks today. So that's fairly straightforward. The pre-recorded sessions you can access down below at the Expo button, and that Expo will also take you to some vendor platforms as well. When you go and then during the networking breaks, if you click on the networking button, that will connect you with one of the other participants who are watching this, and an opportunity to serendipitously meet people that you may have talked to before, or you may not. And finally, up on the right-hand side, there is the chat button, which if you have questions or comments throughout the day, please post your messages there, and we will see that those get funneled through to the speakers. Next slide, please. If you're following on social media or tweeting about this, please use hashtag DSA Global Summit. And with that, I would like to turn over to the president of the Dynamic Spectrum Alliance, Martha Suarez, to introduce our keynote speakers.
Thank you very much, Steve. Hi, everyone. Welcome to this last day of the Dynamic Spectrum Alliance Global Summit. We are very excited about this meeting, and especially I'm particularly very excited to introduce our keynote speaker, our first keynote speaker today. So it is Chairman Pai, Chairman Ajit Pai from the FCC in the US. And I have to say that it is the first time that Chairman Pai is with us, is joining us for the Dynamic Spectrum Alliance Global Summit. So this is great. Welcome, Chairman Pai.
Good to be with you. Thank you so much for having me.
Great. And we have decided that this keynote is really interesting because the FCC has been, in a process of a modernization of the regulatory frameworks, and particularly you have been championing this process, updating rules to match the marketplace realities. And there are so many exciting news in the US in terms of spectrum sharing. So we would really like to hear from you. And please go ahead. The floor is yours.
Well, thank you so much, Martha, for that very kind introduction. And I very much appreciate the opportunity again to be with the DSA at the Global Summit. It is great to be with Dynamic Spectrum Alliance in particular, which for the record has to be the coolest named group I have ever spoken to. I think the alliance part of it is the key. It's so much better than the Dynamic Spectrum Association. I mean, anyone can be in an association. But seriously, Dynamic Spectrum Alliance sounds like something from Star Wars, and you certainly fit the galactic bill, if I might. If you remember from episode 4 of Star Wars, as Commander Tage said, and I quote, "The Alliance is too well equipped. They're more dangerous than you realize." And I think that's certainly the case when it comes to spectrum policy. You've made a real and a positive mark in this area. And all joking aside, it's for that reason that it's a pleasure to be a part of today's important discussion. To the uninitiated, of course, a bunch of people talking about creative ways to more efficiently use our airwaves may not seem like a big deal. But this past month, our little community of spectrum policy nerds, as you might say, got some serious outside validation. And that is because on October 12th, as you probably know, the 2020 Nobel Prize in Economic Sciences was awarded to Paul Milgrom and Robert Wilson of Stanford University. Now, what did these two do to gather the economics world's biggest prize? Well, they were two of the key architects, along with the FCC's Evan Correll and other FCC thinkers, behind the world's very first spectrum auction, which just happened to be held by the FCC in 1994. For good measure, Paul Milgrom also just led the design for our 2017 incentive auction team. And so I think that this Nobel Prize sends a very powerful message that spectrum policy can unlock technological innovation. It can transform our economy and our society, and it can improve the lives of people the world over. And when we talk about spectrum policy innovation in 2020, dynamic spectrum sharing, to me, rests at the cutting edge. It's become a powerful tool for squeezing the most value out of a high-quality spectrum and meeting the growing consumer demand for wireless services, a demand that, of course, is growing all the time. You can find ever more cases on the spectrum chart in which the FCC is using dynamic sharing, which means there are ever more cases that I could discuss in my limited time. But then I saw the Global Summit schedule featured sessions on CBRS, the 6 gigahertz band, and TV white spaces. And this gave me an idea. I should talk about CBRS, the 6 gigahertz band, and TV white spaces. And so here we go. Let's start with CBRS, also known, of course, as the Citizens Broadband Radio Service, also known as the 3.5 gigahertz band. This August, we reached a major milestone for the 3.5 gigahertz band when the Commission successfully completed an auction of 70 megahertz of licensed spectrum in the band, the first ever auction of mid-band spectrum for 5G in the United States. Getting to this point was quite a journey, to say the least. Now, given all the talk about 5G, many might think of 3.5 gigahertz primarily as a part of the push to free up mid-band spectrum for next generation wireless technologies. And it is, in fact, a key part of the FCC's 5G Fast Plan, which I outlined a couple of years ago. But when the campaign began to open up the 3.5 gigahertz band for commercial use, it wasn't about 5G at all. It was more of an experiment. Federal users occupied much of the band, and even though they made little use of it across the country, if they had it, then nobody else could use it. And so for years, the FCC was struggling to square this circle. And then in 2012, we decided to test a theory, a sharing regime that would allow different services to flourish. In 2015, this sharing regime began taking shape. The FCC voted to create a dynamic, three-tiered hierarchical framework to coordinate shared federal and non-federal use. Incumbents, such as federal users, comprise the highest tier and would receive protection from all other users. They would be followed by priority access licenses, or PALs, in the second tier, and general authorized access, or GAA, on the third tier. Now, there were many positive aspects of this three-part framework, but unfortunately, the rules the Commission adopted back in 2015 did not do enough to encourage investment and innovation with respect to those priority access licenses. And so when I became chairman, I knew that we had to institute reforms, in particular, to advance the band's 5G potential. And I asked Commissioner O'Reilly to lead this effort, and that he did. Because of the work that he did, we re-examined the rules governing priority access licenses. Among other things, we determined that the earlier decision to license PALs by census tracts was ill-suited for 5G deployment. And so we instituted instead county-based licenses. Excuse me. Now, we also extended the license terms from 3 years to 10 years, and also created an expectancy of license renewal. Excuse me. These reforms make 3.5 gigahertz licenses much more appealing for 5G operations. And all of this came to a head with the recently completed 3.5 gigahertz auction. 7 10 megahertz channels were made available for a total of 70 megahertz of spectrum. Bidders paid for the right to use a 10 megahertz channel, but they didn't bid on a specific channel. Instead, the spectrum access system administrators assigned frequency blocks for use that may change from time to time as a result of dynamic spectrum sharing between federal and non-federal users, a very innovative system. The FCC auctioned over 20,000 licenses in this auction, the most ever in our history, generating more than $4.5 billion of revenue in net proceeds from 228 winning bidders, including a diversity of bidders from different sectors: mobile wireless operators, cable companies, fixed wireless internet service providers, or WISPs, and others. Now, of course, the auction is only a part of what is so exciting about the 3.5 gigahertz band. Earlier this year, the FCC authorized several SAS administrators, or SAS administrators, for full commercial deployments in the band. As a result, 150 megahertz of GAA spectrum is available right now. Anybody can use it for license by rule operations, and as a result, we've already seen thousands of deployments with use cases that are fairly diverse as well, ranging from transforming the communications system for Dallas Love Field Airport to rolling out new fixed wireless services in rural America. And notably, none of these operations have caused any significant complaints about interference, harmful interference from incumbents. And that is a powerful proof of concept becoming reality. Now, CBRS may have been the FCC's first major foray into dynamic sharing, but it was hardly our last. One initiative that we're really excited about is our work in the 6 gigahertz band. I know you've heard much about this already, but just for background from our perspective, the 6 gigahertz band has long been populated by microwave services that are used to support utilities, public safety, broadcasters, and those who use it for wireless backhaul. Each of these, of course, serves an important function that we need and want to protect. Now, at the same time, the 6 gigahertz band has also been described by a leading industry expert as, and I quote, "without a doubt, the single biggest opportunity in Wi-Fi, and probably a wireless generally, in a generation." So the FCC, we're trying to capture the best of both these interests to protect those incumbents while realizing the value of potential unlicensed operations. And thanks in part to dynamic sharing, we have done that, scoring a huge win for consumers and innovators alike. The top line, as you might know, is that we're making the entire 6 gigahertz band, a massive 1200 megahertz from 5925 to 7125 megahertz, available for unlicensed use. And by doing this, we are effectively increasing the amount of spectrum in the midband available for Wi-Fi for unlicensed by a factor of 5, a gigantic influx of supply. All 1200 megahertz of this spectrum will be available for indoor-only, low-power use without the added complexity of database coordination. We're also making the 2 largest subband segments, totaling 850 megahertz, available for use indoors and outdoors at standard power when accessed through an automated frequency or a coordination, or AFC, system. Now, going big means that we can allow unprecedented 160 megahertz or even 320 megahertz wide channels for Wi-Fi. And this will dramatically ease spectrum capacity as a constraint on innovation and open the door to new high bandwidth applications and services, many of which we can't even conceive today. And importantly, again, we are doing all of this while protecting incumbent services from harmful interference. Our AFC systems will only allow new standard power operations in areas that will not cause harmful interference to incumbents. So that dynamic spectrum sharing approach in this band is allowing much greater efficiency and much greater diversity of use of this scarce resource. Let me close by shifting to white spaces before taking your questions. The TV white space spectrum, which includes unoccupied channels in the broadcast TV bands, UHF, VHF, has several attributes that make it attractive for delivering wireless broadband service to rural areas. The signals propagate well over long distances, over varying terrain, and even into and within buildings. The FCC first authorized unlicensed white space operations way back in 2008, a dozen years ago, and has expanded white space operations on several occasions since then, each time taking care not to interfere with broadcast TV station operations. For example, in 2019, we modified our antenna height rules to allow for improved broadband coverage in rural areas. Now, just last week, the FCC adopted important changes, additional changes to the operating and technical rules for white space devices. And these changes will expand their ability to deliver wireless services in many rural and underserved areas. We allowed fixed white space devices in less congested areas to operate at higher power and increased height above average terrain, which makes sense given the relatively sparse populations and spectrum use in those areas. We created a new class of geofenced mobile white space devices excuse me, that may operate at higher power levels. And we reformed our rules to allow for the deployment of narrowband IoT white space devices. And these rules will permit operation in smaller 100 kilohertz channels at the same maximum power level currently permitted for fixed devices, spurring a much greater diversity and innovation in the IoT space. At the same time, we took the critical steps necessary to ensure that these reforms don't end up causing harmful interference to broadcast television stations, which, after all, are the primary users of the broadcast TV band. For example, we increased the minimum required separation distances between white space devices operating at higher power or height above average terrain, and protected services operating in the TV bands. What's more, we are also looking at whether we can open up even more white spaces for rural operators by incorporating smart modeling into the system, specifically the Longley-Rice Irregular Terrain Model, or LRITM, for those of you who are fascinated with acronyms. Now, I expect that these changes, as well as the ones we have already adopted to date, will spur further growth of the white space ecosystem and help close the digital divide, especially in those rural and underserved areas, which for too long have not had the access to broadband that they need. Of course, that isn't a complete list of everything that we have done in the area of spectrum. There are many other spectrum bands I could talk about, infrastructure reforms and other things to allow the spectrum policies we've instituted to reach full fruition. But I know that we have finite time, just as we have finite spectrum, and so I want to be respectful of everybody who's watching. So I just want to thank Martha Suarez once again for the opportunity to join the Dynamic Spectrum Alliance. I look forward to the questions and look forward to working with you to realize the full potential of the airways for the people of our country and for people around the world. Thanks so much.
Thank you very much, Chairman. That's very interesting to hear all these projects flow. So the new rules for TV white spaces, the results of the CBRS auction and the framework in general, and all the framework for the 6 gigahertz band. So we have a question from the audience. This person is asking, similar to CBRS, is FCC planning to share some other spectrum dynamically between federal and 5G services?
That's a good question. So we are looking at a number of different bands in which there are federal incumbents. For example, recently, the FCC started the process for freeing up the 100 megahertz of the 3.1 to 3.55 band. So this is 3.45 to 3.55. Currently, the Department of Defense has a number of operations in that band that we need to accommodate. And so we're looking at ways to accommodate that use with an eye to auctioning that spectrum by the end of 2021, December of 2021. Whether that involves dynamic sharing is something that we will have to consider. In addition to that, there are other bands we are looking at where there are federal users or federal users in adjacent bands that we need to accommodate. But certainly I think the 3.45 band is the first one that comes to my mind. There are other bands where we're doing interesting things that might involve dynamic sharing, even if there aren't federal agencies using that spectrum. For example, in the 4.9 gigahertz band, there are currently a lot of public safety operations, especially in densely populated metropolitan areas across the United States. And so what we did there was to say that every state, every one of our 50 states, can make a determination on how best to allocate that spectrum, that 50 megahertz of spectrum, the 4.9 gigahertz band. Should it be continued solely for public safety? Should there be essentially a dynamic sharing arrangement between public safety and non-public safety operations in places in times where public safety isn't using it? So there too, you could see the innovative work that the DSA has done bearing fruit in the 4.9 gigahertz band. So I think in all of these different bands, we need to think creatively, and sharing is one of the things that has become incorporated more and more into the FCC's decision-making on 5G policy.
Okay, I also have one question about, I know the FCC right now is considering high frequency bands like 70, 80, 90 gigahertz, and you have a very interesting concept about 3D spectrum sharing. So because we're having the opportunity for sharing between terrestrial and other systems, space or hubs. I would like to hear about, if you can mention just a few words about that perspective and what you expect from that.
Yeah, I'm very excited about this. It's incredible that we're even talking about it. As you know, Martha, and so many on the call know, it's inconceivable. It would have been inconceivable just 20 years ago to be thinking about these bands as usable for anything. But now we've reached the point where I routinely get questions about millimeter wave, even up to the terahertz bands, and above 95 gigahertz. We've done a lot of interesting work, licensed and unlicensed. But specifically in the 70, 80, 90 gigahertz band, I'm really excited about the potential of this band, both here and in space. We've, of course, seen a lot of discussion about that at the FCC, and in particular here in the US. And even when I've visited some countries abroad, they're very bullish on the potential of these bands for the next generation applications, high bandwidth applications in particular, whether it's fixed wireless operations for terrestrial residential broadband service, or even for essentially in-home unlicensed use. So for example, I've met with some of our tech companies that have interesting use cases where they could use it for AR and VR. And of course, that spectrum use in the enclosed setting wouldn't bleed out into the air and interfere with anybody else. And so those are the kinds of things we're looking to accommodate. We've been sitting down with our Office of Engineering and Technology and trying to figure out here, just as we did in the 6 gigahertz band and in other bands, are there ways to accommodate the terrestrial use and other uses in a way that won't cause problems for anybody? And I think here, I think we're on the cusp of some very exciting developments. I don't have anything in particular to announce today, but I really do hope that those discussions, which benefit so much from the input of learned engineers and technologists out there like all of you, will bear fruit in the near future.
Great. We have many questions.
Oh, sure.
I have to take it as possible. So we have one from Yusuf Abdul Kadir. He's from the Nigerian Communications Commission, and he's in he says that they're in the process of finalizing rules for TV white spaces operation in Nigeria. So do you have any specific advice that you could offer to the regulatory administration in Nigeria to optimize use of TV white spaces for broadband services?
That's a great question. And I love my counterparts from Nigeria. Good to see you all, virtually at least, and hope you're well. So I think TV white spaces just in the United States could have powerful use cases in Nigeria. And I've spoken some of my counterparts in Nigeria about the digital divide they face, where there are rural areas outside of Lagos or Abuja and other bigger cities where really fixed white space devices could be powerful for closing the digital divide. And so my suggestion would be to do what we did if you wanted to go down this road, to do what we did in the United States. We encourage broadcasters and some of the white space innovators to sit down at the table together and to really hammer out a consensus framework. And that's exactly what we did. It was uncertain a few years ago whether they would be able to do that, but working in good faith, the two of them who previously had been arguing about this or that technical point actually came to us with a consensus solution because they knew it was important to us to be able to pursue white space operations in this band. And so I think a more consensus-based, privately led, negotiated truce or consensus approach is one that bears much better likelihood of success than the FCC, at least, simply saying by fiat, this is how it's going to be. The second thing I would say is to continually focus on the incremental. I think that one of the things we've learned in this proceeding is that it doesn't have to be perfect on day one. As I mentioned in my remarks, the FCC first opened up these bands for TV white-space operations in 2008. And so what we've slowly done over time is to benefit from not just the technological improvements in that time, but also the proof of concept that, okay, if there's no interference from this white space type of operation, maybe we can expand it. We can increase the heights or the power levels, for example. And that incremental improvement over time is something that's good too. So in other words, the perfect doesn't have to be the enemy of the good. If there's something that everyone can agree on, let's focus on the part that we can all agree on and then work on the other stuff in the time to come. So you just be patient, and I think the benefits will accrue to for the people of Nigeria, just as they have for the people of the United States.
Thank you very much for that advice. We also, now I will move a little bit to the 6 gigahertz band. We have a question from Glenn Fallas from Costa Rica. And he's saying, considering the increasing interest in the 6 gigahertz band for IoT, do you foresee some future possible sharing with unlicensed and IoT in this band? Probably you can also tell us a little bit about that process in the US, because you decided to open the 1200 megahertz. So it would be interesting to hear about that vision.
And sorry, so he was asking about the sharing between...
Yeah, if you foresee some future possible sharing with unlicensed and IoT in this band.
IoT, yeah. Great question. So I absolutely do. In fact, I would argue that IoT could be one of the paradigmatic use cases for unlicensed operations in the 6 gigahertz band. As all of these devices become connected, if you look at the Cisco reports every year, the VNR report, and the number of connected devices going up exponentially, something like 22 billion, I think they expect to be connected over the next couple of years. That's a lot of devices to be on the network, many of them operating as IoT devices, which have, of course, a variety of bandwidth requirements and operate in similar geographic environments and at similar times. And so to me, that sort of smacks of sharing a regime that's going to become very necessary. And certainly for outdoors IoT devices, I think the AFC is going to be incredibly important. And the fact that we have not seen a lot of complaints about harmful interference, I think suggests that there's going to be a tremendous ability to expand the use of IoT in the 6 gigahertz band in a way that doesn't entrench upon some of those incumbent interests. And so I'm very, very excited. And I've talked to some of the people on the innovation side, just asking them, sort of the wild and crazy thinkers, okay, what do you foresee as the IoT potential of this band? And people who are in the telehealth space could imagine healthcare becoming inverted with IoT devices essentially tracking patients where they happen to be, as opposed to in a bricks and mortar facility. Talk to farmers who are very excited about what IoT in the 6 gigahertz band could mean for precision agriculture, essentially tracking different farm equipment and the like as it's mobile. Just so many different things like that. And so to me, at least, sharing is going to have a real chance to prove its worth in the 6 gigahertz band when it comes to IoT. So stay tuned. The future is very bright, and I hope to see it realized here and in Costa Rica as well. Mi mejor país. Fui a Costa Rica en 2007. Oh, excelente.
Yeah, I wonder, probably, I think he was also wondering about license services.
License services. Yes, I'm sorry. Yeah, so here too, I think there's going to be, this is one of the areas. So traditionally in the US and perhaps in Costa Rica as well, there's traditionally been seen as a rivalry between licensed and unlicensed services. If something's devoted to license, then okay, unlicensed, everything is off. And for unlicensed as well, then licensed can't use it. But one of the great things about the 6 gigahertz band is that the 5G NRU specification will allow for cellular use of that spectrum on an opportunistic basis. And of course, they can't, they won't be using the entire band. There's going to have to be some sort of sharing protocol involved so that everybody can use that spectrum. So I think the fact that the technical standard is being developed to allow licensed use of that band, essentially on an LTE-U basis, is going to be very, very important. And so to me, at least, 6 gigahertz, ironically enough, is a tremendous complement to all of the work we've done on 5G licensed spectrum. To me, at least, they're brother and sister. They're not enemies by any means.
Thank you. We still have another question also about 6 gigahertz. Do you have any insight or advice for regulators in other countries who are considering the trade-off of using AFC, automated frequency coordination, to expand or streamline spectrum sharing in bands such as 6 gigahertz, for example. Was it very costly or burdensome from the perspective of the FCC?
That's a good question. So certainly the cost was one of the considerations that people expressed to us when it came to indoor use. And so specifically, they said that applying AFC requirements indoors would make the equipment significantly more expensive. Those costs would have to be passed on to consumers. And in the end, they worried that imposing that AFC requirement would make 6 gigahertz stall with respect to indoor innovation. And so that's part of the reason why we did not require AFC indoors, simply establish a 5 dBm power level and other essential protections to allow 6 gigahertz to thrive without the use of AFC. Now, outdoors, of course, it's a different story because we heard from a lot of people, as I mentioned, those electric utilities and broadcasters and public safety, that look, it's one thing if you're going to allow these devices to operate at standard power, we have to be sure that those transmissions don't bleed over and cause harmful interference to some of our critical infrastructure as well. And there, we thought that the AFC was the best way to go. Recognizing it imposes much more complexity and a little more cost. Nonetheless, we thought that the trade-off was worth it because to allow standard power for those devices outdoors, I think is going to give unlicensed a greater chance to innovate, even though it's constrained by the AFC, than we would have had otherwise. I think the alternative might have been significantly lower power levels and other attendant technical restrictions that I don't think would have served 6 gigahertz unlicensed innovators very well.
Thank you. And I will take last question if that is okay for
Sure.
you.
Oh, this is great. Thank you.
It's very active, the chat. So we have a question. The FCC has previously stated that freeing up mid-band spectrum is the main priority. Can you comment on how high-band spectrum fits into your strategy in terms of timeline?
Sure. So you can find out more about this through our 5G Fast Plan, which is available at fcc.gov/5G. But in a nutshell, the millimeter wave is where we had already done a lot of work. So when I first came on board, we conducted auctions in the 28 and 24 gigahertz bands. Last year, we finished an auction of the upper 39, 40, 37, and 47, upper 37, 39, and 47 gigahertz bands. And so we've been very aggressive there. In fact, that last auction I mentioned was the largest auction in American history, 3,400 megahertz of spectrum made available for commercial use. And so all of those auctions have been very successful. Some of the operators now using them for a variety of different uses. It could be fixed wireless to enhance the reach of their terrestrial networks, or it could be for some sort of 5G service, a mobile 5G service. And so I think people are still experimenting with that. But to me, at least, standalone millimeter wave, at least in the US, has not seemed to be, people are focusing more on a diversity of spectrum assets. So you see our cellular operators, for example, incorporating low band, mid band, and high band into their thinking. And that's exactly how the FCC has pursued it as well. We think of it as an all of the above strategy, that we want to make as much spectrum as available in all of those different segments as we can, and just let the marketplace sort out who's going to be able to use it. But I think that the millimeter wave bands are going to be very important for all of these different use cases, and we'll see how it shakes out. It's a very exciting time in the wireless industry, to say the least.
It is. And Chairman, just to conclude, so we have also very exciting news in the region. Many countries are following the path of opening the 6 gigahertz band for unlicensed access. So we had the recent decision in Chile to open the 1200 megahertz for LPI and for low power indoor applications. And we also had recent consultations in Costa Rica. Peru just published a recent consultation, and Colombia and Mexico have also announced those movements. So we are seeing a lot of momentum. Is there any advice you would like to give to those countries, especially in terms of the band? Because some of them are considering just 500 megahertz instead of the 1200 megahertz. Would you like to give a few words to, and also in other regions or countries that are considering this unlicensed access in the 6 gigahertz band?
Sure. Well, first, congratulations to my friends in Chile and beyond. It's great to hear that they are thinking along the same lines. And we just want to be a resource to them. So if any of them are watching, you can always email me directly at ajit.pai@fcc.gov. I would love to hear about how your consultations are going, how your decisions are being made. And if there's anything that we can do to assist, don't hesitate to be in touch. Obviously, it can be difficult to convey all of the information in a brief answer over the phone, but I really do mean it, though. We want to be able to coordinate with our sister countries around the region and around the world to maximize the benefit of this band for our countries. And I've heard of interest elsewhere as well. Brazil, India, and other countries are interested in it also. So I think the number one thing I would suggest is, I think parenthood is great training for spectrum policy. It used to be the case, of course, when one child is using the toy, then the other child gets upset and can't have it. But one of the things I've learned as a parent and as a regulator is that there are ways to accommodate shared use. And I think that that's something we found in the 6 gigahertz band also, that when you incorporate very thoughtful approaches like AFC outdoors, LPI indoors at a certain 5 dBm power level, you're able to focus on the technical aspects of things as opposed to the policy or political aspects and say, look, we believe based on the engineering that this is a way that we can maximize the benefit of this public resource. And so if there's any help that we can give as you struggle through those issues as well, just let us know. We're always happy to help. And I'm not surprised to hear that the countries you mentioned are leaders. I've got friends in each of them, and I know that they're forward-thinking regulators as well.
Okay, thank you, Chairman. And you mentioned something very important. It's the team that you have at the FCC. So I would like to thank all the commissioners. Commissioner O'Reilly has been also a champion for sharing spectrum, Commissioner Rosenworcel, Commissioner Carr, and Commissioner Starks, and also the great team you had in the past, like that is not there anymore, but the present team right now. So thank you very much for this update, and please also take our thank to all your team.
Oh, absolutely. Thank you for the kind remarks, and really appreciate the words about our staff too. Our engineers and technologists are the best, and we're so lucky to have them. And a pleasure again to be with you. And please do, everybody, be in touch. I mean it. When I say I want to be as responsive and collaborative as possible.
Okay. Thank you. Thank you very much, Chairman Pai. Have a nice day.
Take care.
See you. Bye-bye. Well, so I hope you enjoyed this session with all these updates from the US. And now let's move to Europe. Well, let's move to the UK. So we have also invited to provide a keynote, a presentation, Mr. Philippe Martinique. Philippe is working with Ofcom and has also been leading and championing a lot of initiatives to increase access to the spectrum, to provide the right rules to allow many new stakeholders to access the spectrum. And right now also, I was reading that you're opening the conditions for the auction of 700 megahertz. So I think it would be great to hear from all the updates from Ofcom. And thank you very much, Philippe, for being here.
Thank you very much indeed, Martha. And it's a great pleasure to be at the DSA event. It's only a great shame that I can't actually be across in Paris, which would have been even better. And it's great fun to follow Chairman Pai. So unlike him, I was actually going to use some slides and go through some stuff, both on an update, but also some changes I think we need to make. Because for me, on the slides, as we say in the title, for me, it's making sharing more normal. As we just said, spectrum is a scarce resource. And as we move to the next slide, please, but it's used by almost everything you touch. The world now is totally wireless. Everything uses spectrum. Oh, I'm sure you can find some stuff from my fixed colleagues about these things that go there. But actually new things are moving on to the next slide. You'll see that the new ways of doing things and different sectors are starting to use wireless as part of their business. Precision engineering, out in manufacturing, out in logistics, out in agriculture. Everybody wants to try and use wireless as a way of helping them improve and deliver. But for me, as you see on the next slide, the world we live in and our approach to spectrum management is still very much designed for the world of yesteryear. And this is especially at the international level. We talk in tight harmonization. We look at large coordinated clearance programs, not just necessarily because we clear spectrum, because people get worried that you mention IMT and therefore it means they're going to have to move. We look at coexistence in a way of the worst case upon the worst case scenario. And then in some sectors, we add an extra 6 dB just in case. And we've had people who work in the low license exemption type bands and actually make services which are so dependent that they get worried, even though they're supposed to be sharing, when someone else wants to come along and do something which actually might impact them. So our rules and way of thinking are very different. And as you see on the next slide, we need to, in my view, move to a new way. And just as Chairman Pai was saying, we need to a way of not thinking about how do I keep people off the grass and how do I keep people away, but actually a way of thinking that says, how do I make it work? How do I make new services use the same bit of spectrum that I want to use and actually facilitate other people sharing spectrum? For me, sharing should become more the norm, less the challenge. But if you look on the next slide on some of the stuff we've done, or the things we're going for, we have to ask ourselves is whether our cycles we use at the international level, the ITU, are actually keeping pace with the changes we need to make. And the challenge for that is if they're not keeping pace with it and the speed of which spectrum management needs to keep going, then we will get initiatives in other ways that happen in different parts of the world. And we will look to see how we collaborate to do different things to drive it. So for me, it's really important that we look at the philosophy of which we're doing at spectrum management. We change our slight ways of thinking. We look at what the speed we need to go at to enable us to deliver the solutions for people, or look at frameworks that are now different ways of doing things. So if I go into some of the stuff that we've been looking at and doing, if you look at the next slide, for us, we've had TV white spaces for quite a long time now. It's been there. It actually started, as you've just heard before, in about 2006. And then by the time we got to 2015, we were introducing rules to make it work. So a long program in a bit of things that should be relatively straightforward. But actually a lot of this, some of it was to do with coexistence, and it's in the TV band, so how do you protect TV? But actually the TV band was already shared by PMSC, wireless microphones and others, and actually you get the concerns of those sectors. And some of the concerns are not necessarily just the engineering concerns, but the concerns and what it means for it. We also had to look at and think about how we did geolocation, how we put the rules in place, how you make it work, how you can make something that is not so complex for the opportunities are there. Now, there was challenges in some of the technology. There was also challenges in learning. As you just heard, the US and ourselves were doing TV white spaces at similar times. But actually, in Europe, there was an approach that actually, as we went through the standards process, people were looking at a standard which was slightly different to the US. And in markets which are new, how do you make the right standard that actually encourage the economies of scale and scope? And I think one of the challenges in our thinking and doing it is, how do we learn from others, not say, oh, I have to do something different because. For me, it's how do we make sure these things are going on? Our TV white spaces regime has been going for a while, and we're also looking and reviewing the rules. We're reviewing the rules because we'd like to make it more straightforward. We'd also like to make sure that some of the things people want to do are possible and people can see they can do it, as opposed to worrying about not being able to do it. So for us, it's actually trying to make sure the rules continue to be fit for purpose in this really important area, which has given us a lot of learning about how data spaces work, how they don't work, where they're good, where they're bad, and how you make the rules that are actually applicable to enable a market to develop. So if you move to the next slide. So for us, we also need to think about, as we go into spectrum management and as we go into sharing, we need to ask ourselves a question about databases. We need to make sure databases are useful in whatever name you give them. But we also need to look and ask ourselves the question, are the things that people are doing dynamic? I get an awful lot of people coming along and saying, put every bit of spectrum you have on a database and we'll use it. And then when someone else wants it, we'll go away. And my question to those people is, what service have you got that can give up using spectrum? Unless you've got bands where you can move around, or unless you've got devices that build in the capabilities, most people want consistency in the ability to do that. So for us, it's important to ask the questions. It's also important to ask is, if you're in a sharing environment, what are the right tools to enable you to actually do things? In databases, you also require the equipment to be able to talk to the database. One of the great things we got from CBRS is they're using a lightweight protocol to talk to databases. So how do you use that in other places? How do you encourage and enable an ecosystem to use the similar things to talk? But for me, it's using the right solution for the right problem. And so databases are great things to do, and we're looking to introduce more of them in different types of bands, not necessarily because we think things are dynamic, but actually it gives a good way of enabling people to access spectrum in a very fast way. But we also realize that the databases may not be the right solution in other places. If you've got nice clear spectrum, you've got no challenges, why wait for it? And now I'll talk about some of the bands we've been playing with and the rules we put in place. So if we move to the next slide. As you know, we introduced some spectrum sharing in some bands, in quite a number of mobile bands. We also introduced the capability for people to use already auctioned mobile spectrums in places it wasn't being used by the mobile operators. And we built the rules around that and trying to make them make sense for everybody. We didn't actually wait to develop the databases to do this, because to be honest, we didn't need them. So we put a set of rules in that gave us the flexibility to ask people to move spectrum usage bands in a particular place to help for spectrum management purposes. So we give you a license for a particular place and a particular location in up to a 50-meter square or 50-meter area, or in a particular other area that's slightly bigger. We check to see whether a coexistence works in that area for you, given what else is around, and give people a license. But we also built the flexibility in to say, actually in that place, for some other reason, we need you to move from channel 1 to channel 2 and give the flexibility. We also gave people in the bands we were doing the ability to get spectrum in 10 megahertz chunks to an 80 meg or 100 megahertz chunk of spectrum. And we put the facility in to enable people to do this and the flexibility to do it. We continue to build our database capability in the background, or actually we're going to build an online approach where the device talks to our systems, asks the question, gets the authorization and gets on with it. So for me, it's making the right tool for the right problem. If we move on. We also therefore made our spectrum toolbox really approachable. And for us, we decided we'd introduce yet another part of our framework. We already, in mobile spectrum particularly, have auctioned bands. And we auction spectrum bands where we think there's competitive demand for the spectrum. And this tends to be bands where we think there's a national requirement to roll out for a national problem. And therefore, we've auctioned massive amount of spectrum bands. And yesterday, we just announced the new rules for our auction for 700 and the rest of the 3.6 to 3.8 band that we haven't already auctioned. But we also said we need bits of spectrum to be able to be shared for new applications, for the things we started with, for the things that aren't there yet, to encourage and facilitate innovation for things that we haven't thought about and things we haven't got particular rules or made particular provision for. And we made some spectrum available in prime mobile bands that was already there, and also in the band 3.8 to 4.2, which was a very busy band. And we thought we could make different bits of it available in different parts of the country to enable people to do things. We set rules for both indoor and outdoor usage to enable people to use it. So you could go and use it for factories, you could use it for offices, you could use it for the things you wanted to do. And it was a bands where the ecosystem was either developing or had already developed. Like others, we already have exempt and light license spectrum. Light license is a very light way of getting spectrum. And you may have just seen, we've now introduced new rules for the 100 to 200 gigahertz band. And this was something where we didn't know what people were going to do, but we knew that people would be able to use it to innovate and develop new applications and services and do it in a way that gave them the flexibility to do things. We've set the rules because we recognized in some parts of it, Earth observation and other satellites were operating. So we set very strong rules that made sure there was no interference to any of those services. We made it in a way that worked. This was a very different approach because you were setting rules for things you didn't know what they were or had no idea what they were. So put generic rules in place to enable people to experiment, do things, develop and grow. And we see some of the applications people have been talking about is about checking things for doing precision engineering, some of the health applications for checking for cancers and other things. So for us, it's putting sets of rules in places where we didn't know what people were doing to encourage and facilitate innovation. And we will continue to look at these options as we go forward. So for us, having a clear framework of looking at what bits of spectrum we add to enable all of these applications to be developed and to grow. If we can move on to the next slide. I thought I'd take a couple of examples, and I'm going to take one of mid-band spectrum and one of millimetric wave. And at the top band is you'll see the UK band plan. So you'll see the band from 3.4 to 3.8 gigahertz. In the UK, we were able to clear that spectrum and make it available nationwide to enable 5G services. It's already been, part of it has already been auctioned or allocated some years ago, And actually, most of our mobile operators all our mobile operators have the spectrum and have actually started rolling out 5G. We are going to auction the last bit of it, you'll see there, the 120 megahertz of it, which will auction again for national licenses. But we recognized in this space there was new places, and therefore we took the band 38 to 42. We thought satellite usage continues to be really important, and we know in different parts of the world this band is important in different elements of it because it's good in rain and other conditions. We also had some fixed links in the band, but we knew that actually where these things were, because in the UK our satellite users which are large earth stations, we knew where they were. We also know where all the fixed links are. Therefore, we could make the band available for applications for other people to use it in a bit of spectrum that is now in mobile handsets, in mobile devices, for people doing the sort of 5G on a private network basis, or for doing things in agriculture and doing things where you could do it before the mobile network had turned up. So nowadays, the speed of MNO rollout is not an inhibitor to other people doing things. And also for us, the business model enabling people to either do something with MNO or do something privately in this space. And as you'll have just seen, some of the major handsets have just announced now include this band to enable mobile to take place there. So we set rules that enable this to happen. The FCC, as you've just heard, is doing some slightly different things with CBRS in different parts of the band. And we think for us, driving and developing the ecosystem at a global scale is really important to enable agriculture, enterprise and other solutions to be able to use bits of spectrum, and putting the right rules in place to facilitate its use and making it so that people can use spectrum easily. My overall aim is to make sure that spectrum is never an inhibitor to evolution and development. If we move to the next slide, I decided to take another band. This is another block of spectrum which was heavily discussed in the last WRC. It is the 3.7 to 4.3 gigahertz band. As you'll see there, Europe has tended to take the top part of the 40 gigahertz band. The US has tended to take the lower part of the 39 gigahertz band, and China has got a bit across it. It's also a busy bit of spectrum in various places with wireless broadband and other things. But for me, we need to try, again, this is a great place of where we need to change our thinking. In millimetric spectrum, people talk about IMT and then get worried as if you're talking about UHF. Actually, you can use different ways of allocating this bit of spectrum in different places to enable things to happen. There is already an ecosystem at 3.39 gigahertz, which has been driven out of the United States and other places. And we were looking at some things where railways were needing bits of spectrum to try and provide services onto the train. And we think, actually, we can make that work by using bits of 39 gigahertz. We're also thinking about using the 40 gigahertz band for spectrum for 5G and other services. And some of the blocks have already been allocated in the UK. So for me, it's really important that globally, we think about how do you make all these services work at the local level? How do you make the ecosystem work by actually giving economies of scale for people to do things? And then how do you facilitate and allocate spectrum to people in different ways? And how do you make sure that the IMT tag isn't perceived by everyone else as a get out of my backyard thing, but actually just another tag to enable people to provide services at a local level and continue to make sure that other services exist and you can do it in a way that coexistence works and we can work, everyone together can work around the problems, especially in blocks of spectrum when you've got very large blocks of it. So that's, for me, trying to change the way we think about what we do and how we allocate bits of spectrum. If we can move on. So on the next slide, the other thing for me is really important, and some people may have heard me talk before. One of my great initiatives is trying to think about big ears and loud voices. In most spectrum management things we do, we always think about the transmitters, and we set rules that apply to the transmitters. So how much power you can put out, what your mask is, what you can do things. But actually, in a lot of cases, it's the receivers. It's the receivers that are the coexistence issue. It's the concept of how you design your receivers to do things. So as you see, the neighbor is complaining about the noise coming from next door. So for me, it's really important that people think about designing receivers. Do you actually have, when you design it, something in your head that says, tomorrow, I might get a loud neighbor? And then you think about what filtering you need to put in to make sure that you're not like this guy, you're not bothered by next door's music, you build a suitable wall and the right thing. We also need to think about receivers. Should it be what level of protection you get? How do you put the right incentives for people to build these receivers? How do we make sure that when people think about building receivers, they're not sitting there saying, I'm going to build a really bad receiver, and actually that means I'll stop next door. How do you get the balance right between taking into account what should have been a reasonable design for something and taking something into the other way around? If I move to the next slide, which should be my final one. Thank you. So this is, again, like others, we've opened the 6 gigahertz band for Wi-Fi. We've done it slightly differently. We've done indoors because we think really important that Wi-Fi use indoors is actually delivered and works well. But we've also done outdoors low power usage because we think there's new applications that are coming along that are going to use really low power, personal networks and other devices that can do it, glasses that will communicate with something using Wi-Fi. So we needed to get the rules right that enabled it to work without causing a problem to everything else outdoors. So for us, we're trying to set a set of rules doing that. So it's really important to drive it. I think for me, for anything to do with Wi-Fi, we need to get as much global harmonization as possible and make sure there's no particular parts of the world constraining what others do to try and make this work, to make the ecosystem work. So thank you very much indeed. I'm happy to answer any questions that people may have.
Thank you very much, Philippe. I feel like we share a common goal here, making sure that spectrum is not a barrier, and also, and also many concepts like making sure that there is a right balance between local applications and economies of scale. That is really important for appropriation. So thank you for this presentation. I don't see any questions from the audience so far.
Oh, that's all right. They asked everything to Ajit, so he's great.
The presentation was pretty clear. Yes, we have one. Will Ofcom open up the upper 6 gigahertz similar to the lower 6 gigahertz? What is your vision?
It's an interesting question. We look continuously at what needs bits of spectrum. We do know what the FCC did, and we know that they have fixed links, but they have also high power usage outdoors. We also need to make sure that the rules right across the 5 gigahertz band and the 6 gigahertz band enable people to deliver. So I'm constantly looking at seeing, again, what are the problems we need to fix with it, and do we need to do something? As Graham, who asked the question, knows, there's a question in some parts of the world, should it be used for Wi-Fi, license exempt? Should it be used for IMT? And there's a push for people to use that. And we just need to think about what the right solution is for that bit of spectrum. But also, there's an awful lot of fixed wireless type services in there, and some of the very low speed applications that used to be used on microwave links have actually moved up to that bit of spectrum as they've been unable to lose some of the lower bits of spectrum that have been used for other services. So over the years we've moved a low bandwidth services into this, and we need to think about how we make sure the rules work for everything, not just one particular service. So we're trying to figure out what the right solution is for this band.
Okay, good luck with that project, and especially as you mentioned, Region 1 is also considering that band, for the future of that band. So we will hear about that in the last panel today about WRC preparation. So Philippe, thank you very much for
no problem whatsoever. Thank you for everything. Bye bye.
Take care. Bye bye. Okay, so with this we finish the 2 keynote presentations, and I will give now the floor to Steve for some additional remarks before the break.
Thanks, Martha. Only at this point, just to say that we're running just a couple of minutes behind schedule. We will come back in 15 minutes for the next session, which is on sharing spectrum while protecting incumbents through multi-stakeholder collaboration. Look forward to seeing you then.